Hey everybody, it's the Crypto-Anarchist here, and I'm bringing you a video on cryptocurrencies. In today's video, it's going to be a response actually to a recent article by Craig Wright called A Call to Arms. And so this video, I'm going to title it A Rise to Arms, but also it's a challenge to the professor, and by the professor I just mean Craig Wright. My challenge to the professor is this: we don't really have, like, entrepreneurs who aren't computer programmers do not really have the weapons to help you out in this fight. Like, I can try my best, and um, I have this YouTube channel in order to help educate people on cryptocurrencies, but as of right now, I'm kind of neutered because the weapons that I require in order to help you fight this fight don't really exist, and I can't build them. So in this video, I'm going to show you sort of a protocol that I need, or it's an application. Like, I'm going to show you the protocol, I guess, for an application that I need built, and I'm going to show you how this protocol would work. But again, I'm not a computer programmer, so I can't build a program that follows this protocol. I just know the type of protocol that I need. And the reason why I titled this A Challenge to the Professor, and sort of what that challenge is specifically, is it's simply that the professor says here in this article that he can compete in any field he touches, right? So he says if he goes into it, he's going to compete at a high level, and he's going to build things that are going to be great. Well, I'm going to show you something that I need built for myself that could, put billions of transactions on the blockchain per year. It should be pretty simple to build. And then if you extrapolate this idea to incorporate not just like, I'm going to show you a board game I'm trying to build that you could use this for, but you could use this not only for board games, but for movies, TV shows, for video games, for the radio, for basically anything that involves the transfer of data. And you could put a massive amount of transactions on the blockchain using this. But let's just go ahead and just jump right into it. And I guess the reason, before we jump into it, I guess the reason why I'm bringing this up, and I'm bringing Craig Wright up, is because he recently linked a video of mine where he said some people are starting to get it. And I wasn't actually that surprised when I saw this. Of all the people within the cryptocurrency communities, I agree with Craig Wright the most. He and I only disagree on the block reward. I'm not going to get into that issue right now. He says my stance is that of the central planner. I think he's actually the central planner as far as the block reward goes. But that's a completely different argument. We're not going to talk about this right now. But I wanted to title this specifically at Craig Wright because of his article. Again, his Call to Arms article. I don't have the weapons to help you in this fight. Like, I can try, and I'm doing what I can right now, but I'm neutered, so I can't really help you all that much. But I do want to reassure him that there are people out here that are trying to build things. Like, I've been building things in anticipation of these applications already coming out that would help me build what I want to build, but these applications just simply don't exist yet, so I'm just sort of sitting here waiting with my projects that I want to put on the blockchain and put to use on the blockchain, but I can't yet because this application doesn't exist yet. So I'm going to show you guys in detail what application I need and the protocol that I need, and what I need my computer to do. And again, I'm not a computer developer, I'm not a software developer, I'm not a computer programmer. So the words that I'm using to describe this to somebody who is a software developer, like, it might sound sort of wrong the way I describe it, or my definitions of things. I can't help that. I'm just an entrepreneur who understands Bitcoin from an economic and entrepreneurial standpoint. Again, I've been learning a lot from Craig Wright recently. That's why I wasn't surprised when he tweeted one of my videos out saying that I understood Bitcoin, because he and I agree on basically everything there is to be said about Bitcoin except for the block reward. So, wasn't surprised at all, but I just wanted to ask the professor, why on earth does this application not exist yet, and why are people, I'm going to compare my application to the application that's being used on things like Memo.cash and BlockPress, because Memo.cash and BlockPress are terrible. And it's because they don't use hashes and they don't use Merkle roots for the storing of their information, and it really irritates me. But again, the way that you guys you need to re-understand blockchains, and let's just look at this this page here. This image right here at the beginning is not going to make a lot of sense to you. It's just a bunch of different hashes, and we're going to go through what each one of these hashes represents. Specifically here, just to show you guys how I envision blockchains using hashes and Merkle roots to make it so that they store the absolute minimum amount of information necessary, but they still store all the necessary information. And so the reason why I'm giving this video response directly to Craig Wright is he's the only person, again, that I keep saying, he's the only person within cryptocurrencies that fully understands Bitcoin from an economic and entrepreneurial sense. And what he keeps saying about building applications on Bitcoin is that, or on Bitcoin Cash, is that they need to be built efficiently. Okay, so you'll use hashes and zero knowledge proofs and things like that. And so for this application, what I need to do is I need to guarantee my, we'll call them intellectual property rights. I don't like the term intellectual property, and I know a lot of people are going to get on me for this because, you know, I'm an anarchist, I'm an anarcho-capitalist, a Rothbardian, but I believe in intellectual property, I guess you could say. I don't believe that you can own knowledge, I just believe you can own digital goods. So any digital good you create, it is scarce. You can copy it, obviously, but even if you copy it, you can't have an infinite number of copies. There's no such thing, even in the digital space. And if you look at hashes of different digital goods, they're different. So you know for a fact that digital goods are scarce, so they can be owned. And so this application we're going to be talking about is just regarding the ownership of digital goods and how you can fractionally divide this ownership amongst a large group of people in really intricate ways on the Bitcoin Cash blockchain for just pennies. And if you try to do this in the real world, it would cost you, you know, even if you had like some sort of massive corporation of lawyers set up, it would still probably cost you like $5 a pop at least, even if you set up like the most efficient sort of like McDonald's style lawyer corporation for this. But with the Bitcoin Cash blockchain, you can do it right now with, you know, fees of just 1/3 of a cent per transaction. And so what I'm going to show you is just what I'm trying to build for my board game. And this board game, it uses cards that look, you know, sort of like Magic the Gathering cards, or sort of like, you know, maybe Pokemon style cards, things like that. It actually has maps that are built out, and there's characters that you choose, and it's basically like a MOBA style team battle game, maybe kind of like Overwatch or something like that. The game itself is not important. I'm just trying to show you guys this protocol here. So again, looking at this list of hashes, this first item on this list, H1, and H1 just stands for hash 1, that's the Reichstrack World Cleaver. So if we look at this entire file, it's actually all the information that I have for this character for my board game. And again, remember, this is just a text document containing all the information for what I need created for my board game, for this character in particular. So this guy's name is the Reichstrack World Cleaver. You can see all his base information right here, like his health. It's all his character information on that first page. Second page has his attack cards. There's 52 attack cards that have the attack and defense values as shown here. The number on the right is the number of each attack card that he has, and so if you add all those up, it should equal out to 52, and I think it does, just adding those up right now. And then there's action cards as well. So if you look through all his action cards here, this isn't all of them on one page. That's 5 out of 7. There's 26 total action cards. Here's the other 2 types of action cards that he has on this next page. And then there's 13 special cards, so almost all the special cards are on this page. There's one final page with one special card right there. But all this information, this is all the information of the character, as well as the you know, the attack cards I need, the 52 attack cards I need made, and the, you know, 26 action cards and the 13 special cards. So these are all the different parts of the product that I need for this specific character. And just so you guys know, for this board game that I'm creating, there's 36 main character types or species, 36 main species, and each species has 3 subcategories of warriors that you can choose from. So there's 108 characters total for this game, and I don't have them all completed yet, but this is just one of 108. So if you can, you know, imagine all the amount of work that I have to do, that's quite a bit, obviously. But I also need artists to complete this work for me. So if you try and think of, you know, how long it would take me to complete this all by myself, it's going to take me forever. And I don't understand, I'm not very good with, you know, graphic artistry as of right now. It'd be better for me just to have somebody else do this work for me. But the problem that I run into, and the problem that any sort of writer runs into, or anybody who creates digital goods, is that you run into this problem of intellectual property that, like, if you're just an amateur and you try and organize with other amateurs, they can just steal your stuff real easily because you don't have the assets and you don't have the money to go after them, and so there's no way that you can stop people from stealing your work and just making money off of your idea. Okay, and so that's the issue that you run into. However, if you use a blockchain, you can actually hash your digital good and put it on a blockchain to prove that you have ownership of it at a particular time. And then the other thing that you can do is by putting it on a blockchain and proving you have digital ownership of it at a particular time, you can also let other people use that digital file, and you don't have to worry about them stealing your idea, because since you put it on the blockchain, like, proof of your ownership already exists on the blockchain. And so if they try and put the same digital file on that blockchain, they won't be able to get away with it. And I know a lot of people are going to say in response that, hey, if they change the digital file, it changes the hash, and that's true, but that's where you have to actually go to common law, what I would call common law intellectual property law. And again, I don't like calling it intellectual property, but it's just who owns the digital goods. And if someone tried to put, like, if I have this up right now, if I were able to hash this, and again, we can go back to this first page I have here, the entire file itself is the first hash, the Reichsstrack world cleaver. That hash right there, it's just E7, it starts with E79, ends with 4B9. If I put that on the blockchain, if somebody else, just alters that file slightly, even if they put it on a blockchain, since my transaction would occur on that blockchain before theirs, mine would, for the most part, supersede theirs, you know what I mean? So since I put it on there first, if someone else put one on there that basically copied the exact same thing, except, they just put a space, somewhere in the file, because if I were to save that file as a new file and just put a space somewhere, that completely changes the hash. And actually, technically speaking, when I hash that file, I think if I save it at a different time, I think that'll actually change the hash as well. But if you change that file in any way whatsoever, it does change the final hash that you come out with. So if it were changed in any one, I wouldn't have E79 something, I'd have something random again. But again, if somebody puts that on the blockchain, if they put it on the blockchain, they put that on the blockchain after me. And so you can examine the two together and you can say, well, did they steal the idea or not? And so it's all on, by putting it on a blockchain, you completely, you make intellectual property a lot easier, like, you make all the intricacies of it a lot easier to figure out for amateurs. Because now what I can do is, with this hash, I could also hash the, what specifically I need done as far as the work that I need completed. Because again, the whole point of this, the whole point of me putting a hash on the blockchain of my project is so that I can share it with other people without fear of them stealing my idea. So what I actually need done here is for this Reichsstrack world cleaver, for this first page here, this information is all his character sheet information. So I need this picture, I need his health information on there, and I need all the other sort of character information on a character sheet that would look something like this. And just so you guys know, this character sheet is a character sheet from the game Star Wars Epic Duels. And so the only main differences here are that I have additional information, additional character information that I would need on this character sheet that this character sheet format does not have. And again, the character sheet format for this Star Wars Epic Duels, it's Jango Fett and Zam Wessel. It's a minor major character combo, so it's like one character, but there's two sort of sub characters within it. Like for the Reichsstrack world cleaver I have, it's just one major character. There's no minor character for him. And so his character sheet, there would just be one person with one health bar. But the only thing that's different from this format and the format I need, other than that, is that since my health is in higher units, I use units of 100, and there's my character has 13,000 health, so it's 130 units of 100. You would need to use like an abacus style way of showing your health. So that way, like, you just need a different way of showing your health because there's more units here. So you need something that would show things in powers of 10. So that's just the only sort of information I have for as far as the format is. But again, this is what I need completed, is some sort of character sheet format for that information that I have before, which again is just this information here. It's just that picture and then all the information below. So if somebody was a graphic artist and they knew how to complete this, again, if I put a hash of this information on a blockchain, then I can say, okay, this is mine. Then I can put this on some sort of like application, some sort of public application where people could come look at the the projects that I need completed. And if they're a graphic artist and they look at this sort of game and they're like, hey, this could be a cool game, this could be worth my time, investing my work energies into, they might take what I need, like they might come up with some artwork that they have for the type of character that I want, and then put that all on some sort of character sheet, and have a template for me, and they might figure that all out for me, and then they'll come up with they'll come with that template to me, and they'll be like, hey, I created a template, do you want to use this for your game? And so if I like the template, then I can say yes, I want to use that for my game. So then me and this person, this graphic artist, we can enter into some sort of multi-signature agreement where we each put a hash of not only the template that they create for me. So again, if they finish up a character sheet for me, for my Reichsjack World Cleaver, then we would put this template for this character sheet or whatever that they created for me. We would hash that, but we would hash that with the contract, the new contract of ownership of that digital good would just be included in the hash we put on the blockchain. So the hash that we would have, again, it would say now, or it would include not only the character sheet, the new character sheet they had created for me, but then we would also say, hey, so the graphic artist that created this has now a 20% stake in future profits associated with the sale of this digital good. And so you could have something like that, so then later on, if this digital good ever gets sold, all the profits that go to this digital good, they get immediately distributed not only to me as the person who's creating this game, but to the graphic artist who helped create the character sheet. And so if you think about this, since obviously this game that I'm creating is very much in beta form, I don't even have artwork yet for it, I can get just some amateur to do this for me, and they might do this for me, and I might not finish the game for maybe 5-10 years. I told you guys there's a lot of things I have to complete for it, and even if I complete the game, just having an idea is not enough to bring it to market. I would have to get investors interested in it, but I could just have this game completed and the artwork completed for it, and I could just hold on to this forever. And since all this information for the contracts would be done on the blockchain itself, I wouldn't have to worry about losing the contact information for this person. It's all on the blockchain, and then everything it would be done or completed through the blockchain, so that any profits that would go from the sale of this character sheet, since it would go to a particular address that we had created, when we actually agreed on this contract, and we already agreed on who owned the different profits that came through this address, everything would be automatically distributed, and we wouldn't have to worry about this. This all gets done automatically. And obviously, if you create an application like this, whoever creates the application, they have to make sure that their application works, and so long as the application works, it's done automatically. But that's what I need. That's what I need, and that's how I need a blockchain application in order to complete my entrepreneurial project. And again, this is the reason why I'm saying to the professor here why I'm neutered, is because this doesn't exist. And the way that you would put this on the blockchain, again, you only want to put one hash for every action that you do on the blockchain. So my initial transaction on the blockchain would actually just contain the root hash of all this information. So again, the entire overview of this character would be just the hash number 1, that starts with E79 and ends with 4B9. And you guys can follow along with these hashes if you want. You can hash them yourselves and make sure that I hash them correctly. I'm pretty sure I did hash them correctly. If not, you won't get the same result as me. But the second hash here is just the character sheet. The character sheet is not only this first page right here of the character that I have, but again, it's just the information of what I want done and how I want it completed. This character sheet, the hash of that, of hash 2, is just, it starts with A68 and ends with BF5. And so when you hash 1 together and hash 2 together, you get 8B, or a hash that starts with 8BD and ends with 149. Okay, so the other hashes that we have here are the attack cards. And so if we look at the attack cards, in addition to the information that I have, this is hash number 3. It's just, again, it has those Star Wars Duels attack cards and exactly, the attack and defense values of the cards that I have. If you look at this right here, you hash this file, and the hash of this file is H3. It starts with 46F, ends with FE3, and you hash H3 with H4, and H4 is the hash of the action cards. And so when you look at the action cards here, the action cards, all that they are is it's just these 26 cards here. And again, the action cards would look something similar to Magic the Gathering, like these Magic the Gathering cards here. And you know, it just has some, again, it just has a backdrop of the character doing something, and then it has a description of the card and when the card can be used. Okay, so there's 26 action cards. That's hash number 4. So hash number 4 is FA1. That's what it starts with, and it ends with 515. When you put hash 4 with hash 3, you hash these together and you get, it starts 218, ends with F4A. Okay, so this is important because when you put these, again, you put these all in Merkle roots, and I've been saying whenever you do these, when all these videos I made before, you have to put these in Merkle roots because these Merkle roots are what makes the whole thing scale. And all a Merkle root is, again, it's just when you have hashes, you combine them or you organize them in a way that makes it so you just hash one hash with another hash in order to validate any one particular branch of hashes. So again, hash 4 was your action cards. Hash 5 is your special cards, and if you have hash 5 is the final bit of work that needs done for this item. And so hash 5, the special cards, again, if you just look at them, it's just these 13 cards right here. And it's, again, they would just look like these Magic the Gathering cards where you have some picture of the character doing something, and then you have a description of the cards down below. And so the hash of hash 5, the special cards, it starts with 1FA and it ends with 8E4. Okay, and so you combine, or the way Merkle roots work is they work by factors of 2. So since we had 5 things that we're hashing together, we actually have to have, you know, you have to do the Merkle root as though there's 8 items, even though there's not 8. It's just that the hash 5 just stays hash 5. Or technically speaking, for Merkle roots, you might actually hash the hash of hash 5 and just keep redoing that. So on the one side, we had hash 1 and we had hash 2, and we hashed those together. And we had hash 3 and hash 4, and we hashed those together. On the hash 5 side, it just stays hash 5 the whole way through. And so then you just the hash 5, which is just 1FA, ends with 8E4. You hash that with the result of the hashes 1 through 4 hashed together. And so that's what you have down at the bottom for your root hash. And your root hash is just all the information contained in one hash. It's just a hash of all the items all hashed together. And so for this root hash, since there's only 8 items, it doesn't seem like you're getting a huge amount of scaling benefits. But if you had a, you know, some sort of item that, you know, has thousands of different pieces of work to it, and if you're working on something like a video game, you could have like millions of different bits of work for a full video game. So your full video game would have one root hash, but then all the bits of work that would represent all the individual parts of that video game, you know, you would have millions of hashes put together. And again, the whole reason why this is important, why you do this with the Merkle root, is because the Merkle root scales logarithmically. So it doesn't matter if you're getting billions or even trillions of hashes to find a Merkle root. It doesn't take you that many calculations to get there. It takes very few whatsoever. So our final root hash for all of this information here would just be 35C, you know, 09BF, and that's all that I would put on a blockchain. Okay, all you put on the blockchain is that final root hash. And then again, the whole point of putting this root hash on there is then anyone who's looking at this, like let's say you're trying to work on this project and you want to do something for it, instead of having to look up every single transaction in the blockchain, like if the only thing you want to create are the attack cards, and you want to, like when you create these attack cards, you look and you see who the person is, and you're like, is this the actual person who I think it is, or is it an imposter? If you just check the Merkle root, you can check the Merkle root for the attack cards, like just starting with the attack cards individually, and then you know, you just query up the other hashes that you need. And since the attack cards are H3, the other hashes you need would be H4 to get, you know, then you hash H3 and H4 together, and then you need hash 1 or hash 1 2, and then you hash, you know, those two together, and then you need the hash of 5, 6, 7, 8, and you hash those two together, and you get the final root hash. It's only 3 hashes that you have to do to get the final amount that you have. And then if you actually wanted to compare those against all the other bits of information that I have for my game, again, remember I said there's going to be 108 characters total. You might have those characters, all those root hashes would be contained all together in another root hash that's all contained, or contains all the information for all the characters for that game. Okay, and so if you look at this, you can verify the integrity of the information, and this is super important, again, because if you're an amateur, you you want to make sure that when you're working with somebody that you're not working with the imposters. We see all these imposters on Twitter and stuff. If you have Merkle roots that define different work that you have for people to do, and it's all the information that you contain on the blockchain is contained in your off-chain application with with root hashes and things of that nature. You can verify the integrity of that information real quickly, and you don't have to worry about like, who am I working with an imposter. You know for a fact right away whether you are or not. And so this is the sort of protocol that I've been talking about. And again, I hope this video was a little bit more educational for you guys. I hope this made sense on the type of protocol that I'm talking about, and why I keep saying, everyone who's building applications on top of Bitcoin Cash, they're doing it wrong because they're not using hashes. You don't actually put the entire information on the blockchain. Like, again, if the people at memo.cash were building this application I was talking about, they would almost be trying to put like this image on the blockchain and then all this text on the blockchain. You don't put that on the blockchain. You hash all this data, and even the hashes of the data that you want to put on the blockchain, you put those in Merkle roots so that you can have the hash of a hash, and then that still contains all the relevant information without having to put all the individual bits of data on the blockchain. And so you do this all in an economical sense. And again, I'm not saying that you don't want to keep all the information saved for your project. Like, again, for this project, if we look at these attack cards here, I'm not saying like I hash this, put it on the blockchain, and then delete this text document I have. But you've got to remember, these people who are trying to save these things on the blockchain, they already save them on their own personal computers already. If they want to save them on some sort of cloud storage system, they can. That's fine. But you don't actually store things on a blockchain. You store proof of its existence on a blockchain. So you just hash it together and you put the hashes on the blockchain. That's what people keep getting wrong. The only time that you actually put something on the blockchain is when you're trying to put some sort of transaction on the blockchain. And again, the way you've got to think about the transaction in this case is that I'm trying to create a transaction where it's like I want to offer someone a job to complete some work for me, and if we can turn that work into a project that one day we sell for profit, then like I will give them profit for that. But the transaction is just, hey, I've got some work to do. I can't pay you yet, but if you do the work, then I will give you equity in that project. That's the transaction that I'm creating, okay? And so this is the way people need to think about ICOs and think about creating applications on a blockchain. Is one, it's not the money first, it's always the work first. Like when Bitcoin's proof of work, the applications that you build on Bitcoin are also proof of work as well. You don't ask for money first, you ask for work. You put in the work first, and then once the work is completed, then you get the money, okay? It's just like when you find the proof of work in proof of work mining, you have to find the exact, like the golden hash, you know what I mean? If it doesn't have enough leading zeros, you don't get the Coinbase address. And you should think of blockchain applications in the exact same way, okay? If you don't have the work done for the project, you shouldn't have anybody putting any money into it whatsoever. You can fully complete the project, at least the digital aspect of it, without putting any money into it whatsoever, okay? And that's the way you really need to think about these things. So I hope this, helped make my stance on this point a little bit clearer. I know this is a long video, and I know you have to be able to think abstractly in order to do this. And if I guess the professor, if he watched my response video to his call to arms, thanks for watching all the way through. I don't really expect him to necessarily watch. I'm hoping more so that this goes out to his community, and some of the people in his community can help me build me this application, because like I said, like just for my board game, and this isn't the only board game I have created, but just for this board game and just for the characters. Remember, this isn't just a board game that has characters, it has maps. There's a lot of different maps, there's rules, so you have to write out the rules and stuff, but just for the characters alone, if you look at this right now, for this character, for my guy, it's called the Reichstrak World Cleaver. There's the character sheet for him. Okay, on this character sheet, there's only one character sheet that needs to be built for that, so that's one piece of work. But then if we look at the attack cards, there's 52 attack cards, but there's 8 different types, so that's 8 separate pieces of work for this Reichstrak World Cleaver, plus the character sheet, so that's 9 pieces of work, right? And so then if we go to the action cards, for the action cards, there's seven different types of action cards. So that's 7 more pieces of work. So 7 plus 9 is 16. And then if we go to the special cards, there's 5 separate types of special cards. And so 5 plus 16 is 21 pieces of work. So if we assume there's 21 pieces of work for each one of the 108 characters that I need to do, that alone is, that's something like 2,000 transactions that we needed, or I need to do on the blockchain. And so you can extrapolate even further from that. If you just think of all the writers in the world that are trying to create board games and how many transactions they would put on the blockchain, like it's an insane amount. And if you think about it too, because again, I'm just one writer who does this. There's probably thousands of people who do that. So if you put on 1,000 different projects like that, 1,000 times 2,000 is 2 million transactions. That's a huge number of transactions you would put on the blockchain. And then if you extrapolate even bigger from that, like you could say, what if 1,000,000 writers put a million different projects on the blockchain like this? Well, 2,000 times 1,000,000 is 2 billion transactions. And then you can extrapolate further from this and say, well, what if you use this not only for board games, but what if you use it for like musicians? And so musicians put hashes of their music up on the blockchain so that they can, take other people's music and incorporate it into different songs, and they can fractionally divide up the ownership without ever having to meet these musicians or know anything about them, and they can just do it for just pennies, what I'm talking about. If you do that for musicians as well, then that's, billions more transactions you're putting on the blockchain in every year. And then you can say, well, what about for movies? What about for video games? And if you think about this, like, this is how you scale Bitcoin. This is how you put people on Bitcoin who don't know anything about Bitcoin or care about Bitcoin, is you build these applications where you need to use Bitcoin, but you're not using Bitcoin for the money aspects, you're using for the information flow aspects of it, for the just proof of things happening at a certain point in time. That's what a blockchain does. It's an immutable ledger, so you can't reverse things that you put on a blockchain. So since you can't reverse things that you put on a blockchain, the thing that it's good for is it's good for proving things. Like, hey, like when you finish some sort of work for a digital asset, you just put it on the blockchain and you just say, hey, I completed this, just so everybody knows, just for future reference, and that's all you're doing. Okay, that's all you're doing. But this has massive implications for digital assets, and for the digital industries. And these digital industries are, it's trillions of dollars every year that flow into these digital industries, these tech industries, the Hollywood sort of industries, things for writers, video games, stuff like that. And we can completely dominate these industries, but you have to use these hashes, and you have to understand how Merkle roots work. And again, I'm not a programmer or a developer, so I might not have completely described how these Merkle roots work in the best, like I might not have shown you guys the most efficient protocol, but you guys are smart, you can figure it out. Again, I want to thank anybody for watching this video all the way through, but this is how the applications need to be built on Bitcoin. And again, this is a challenge to the professor and to everyone involved in Bitcoin and Bitcoin Cash. Like, why did these things not exist for me yet? Again, I can't build these, like, or at least I can't build them yet. Should I just try and learn how to code? I know some basic coding. I took some very basic coding in a couple college classes. But I don't even know where to start. Like, what language would I want to learn if I want to build this sort of application? I don't know. Should I actually try and learn this, or can somebody just build it? It's not that complicated. I showed you guys how to do it. It's just you got to put hashes together and you organize them in a pretty simple manner. It shouldn't be hard to code that at all. You should, even if you're a bad programmer, you should be able to do it. But that's my challenge to the professor. Why doesn't this exist? But again, I hope you enjoyed this video. There will be more coming out soon.